Hi, I'm Dr. Kristen Skendel, Associate Director of the Gemstone Program.
And I'm Dr. Frank Cole, Professor in Environmental Science and Technology, and I'm Director of the Gemstone Program.
Professor Jeff Clauda from Chemical and Biomolecular Engineering.
I'm Siddhartha Das. I'm Assistant Professor in Mechanical Engineering. I'm the mentor for the Team Bacteria.
Okay, great. And with that, Team Bacteria, you may begin.
Okay. Hello, everyone. Thank you so much for taking the time to come here today. My name is Wing Mei. This is Jackson and Julia, and we're representing Team Bacteria. Although we started with a focus in bacteria for our project, the current literature has led us to believe that an enzymatic mechanism could reduce asphaltene flocculation. So, oh, thank you. Okay, before we begin, this is an overview of our presentation. We'll first talk about the background information and the significance of our project to the field, as well as some current research in the field and our research questions and hypothesis, proposed methodology, and timeline and budget for the next few years. So the big picture is that we need a more sustainable method to meet global energy demands. The International Energy Agency has predicted that global energy demand would increase by 47% by 2035. However, alternative energy sources are still relatively inefficient compared to fossil fuels, and it would take a lot of money and time in order to transition from fossil fuels to renewable energy infrastructure. So this is why we need new technology for extraction and refinery of heavy crude oil and bitumen, specifically from oil sands such as the ones in Canada. And this would provide us with access to 2.4 trillion barrels of crude oil, which could power the whole world for nearly 70 years at current usage rates. However, this wouldn't be easy to accomplish because there are some faults with pipeline transportation of crude oil. Asphaltenes are a component of crude oil, which I'll talk about more later. And they stabilize water and oil emulsions, which can lead to pipeline corrosion. And this can lead to the rupturing of pipelines, which could leak a lot of crude oil into the environment, which is devastating for wildlife and humans. Also, asphaltenes lead to the high viscosity of crude oil, and this also makes transportation difficult because it takes more pressure to move the crude oil through the pipelines. And the main focus of our project is actually asphaltene flocculation, which is the tendency of asphaltenes to aggregate together. As you can see in this picture, they're all around the interior of the pipeline, and that is also why the asphaltenes have been given the nickname cholesterol of pipelines. So oil companies have tried to solve these issues with pipeline transportation by treating the asphaltenes in the crude oil with harsh chemicals and high temperatures. And this leads to the generation of a lot of chemical waste that gets deposited into tailings ponds, which are huge pools of toxic refuse, such as the one pictured here. This is in Alberta, Canada, where the Athabasca oil sands are generally processed. And also the asphaltenes, or the chemical waste. The chemical waste from the tailings ponds can seep into the groundwater and leach into rivers, which is also harmful for the environment. So we've talked a lot about asphaltenes, but what exactly are they? They're a component of heavy crude oil that contribute to high viscosity, and they're also heterogeneous in structure. However, they're composed of hydrocarbons, oxygen, sulfur, and nitrogen. This is one possible structure of the asphaltene molecule. And also, asphaltenes are defined as being soluble in toluene and insoluble in N-heptane. Asphaltenes also flocculate, which, as I said before, is their tendency to aggregate together into clusters. So this is a hierarchical model of the asphaltene structure. It starts out with a molecule of the asphaltene, and then they aggregate together via the van der Waals intermolecular interactions into nanoaggregates, and then they further aggregate together into clusters of asphaltenes, which are called flocks.
Okay, so from our literature review, we found several existing methods to recover heavy crude oil. One such method is called microbial enhanced oil recovery, or MEOR, and this method uses microbes to recover the oil. So we plan to use a similar method using enzymes instead of bacteria, and there's many enzymes catalyze the reactions that break down the asphaltenes to reduce the flocculation. So there's many advantages to using enzymes over bacteria and then over other methods. It's easier to work with, they're easier to standardize the experiments with. They can also be used in situ applications, or like directly in the field you can apply them. And they also have the potential to reduce the amount of harsh chemicals normally used in other processes. So we researched many different enzymes and we came up with 3. Lactase catalyzes the oxidation of phenols into ketones. Chloroperoxidase uses hydrogen peroxide to break down aromatic rings by adding hydroxides. And dioxygenase uses extradiol or intradiol cleavage to open aromatic rings. And this leads to our research questions. What combination of enzymes can most effectively prevent flocculation of asphaltenes? What kind of change will this combination cause to the structure of asphaltenes and the rate of flocculation? And so we posit that the combination of enzymes will be most effective at degrading asphaltenes such that it decreases the rate of flocculation of the aggregates and bitumen viscosity. And so this is a proposed mechanism that we think would occur in the combination of enzymes. There's many different ways that this can happen. So the enzymes can react in different orders, creating different products. So this is just one example of what we think is going to happen. And so first, dioxygenase is going to open up this ring here and create a carboxylic acid and a hydroxide group. And that's just the asphaltene you start with. And then this is the product from the first step, and then lactase is going to come in and oxidate this into a carbonyl group. And then it also produces water. And then chloroperoxidase with water is going to come in and form an epoxide here, and then it's going to open it, creating 2 hydroxide groups.
So for our research, we're going to conduct this in 3 stages. Stage 1 will involve separation tests of the asphaltenes. Phase 2, we'll treat the asphaltenes with single enzymes, and then test them, and then analyze the data using scanning electron microscopy and X-ray diffraction, or SEM-XRD. And then phase 3, we'll see combinations of enzymes we'll treat the asphaltenes with combinations of enzymes. And these combinations include lactase, chloroperoxidase, dioxygenase, and lactase, dioxygenase, and all 3 together. And then we will also conduct SEM-XRD with those tests. So for the asphaltene purification, we'll obtain samples of asphaltenes from the Center of Oil Sands Innovation Laboratory from the University of Alberta. We'll purify these samples and then weigh and dissolve in toluene. We'll observe the structures with SEM-XRD and prepare different concentrations of asphaltene toluene mixtures. So for the separation test, which is our benchmark, we're going to test the asphaltene precipitation with addition of an alkane such as pentane and heptane. And this is a general curve of what we expect the asphaltene precipitation should look like in the most ideal sense. So for the single enzyme flocculation test, we'll have to test the precipitation after treatment of enzymes. We'll vary the concentrations of each enzyme added to the asphaltene toluene solution and then repeat the N-alkane and N-alkane precipitation experiment. We'll plot the mass fraction asphaltene versus the weight percentage of N-alkane for each concentration of enzyme, and then perform SEM-XRD. So for this analysis, I should probably talk more about what SEM-XRD and also what FTIR are. in order to actually properly understand what we're trying to do. So FTIR, or Fourier Transform Infrared Spectroscopy, measures certain functional groups in the molecule, and if we test before and after with the asphaltenes, if we can measure the peaks that occur right here, like there's peak, 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 those peaks indicate functional groups. So if we see presence of new peaks, then we'll understand that we have caused a change in the asphaltene molecule. SEM, it uses focused scanning electrons to provide a topography of the molecule and give more of a macroscopic view of it. And then XRD just focuses on more of the actual structure of the asphaltenes by observing, again, the peaks, but not so much of the functional groups, but more of just like aromatic rings, double bonds, the actual structure of it. And then the enzyme combination test, we will again do the same procedure that we did with the single enzymes, but we'll have the combinations that I stated before. And we'll control the temperature and pH to keep those confounding variables out of the whole equation. And then we will also perform SEM, XRD, and analyze the data. So the expected results in data that we hope to conclude, we'll reduce the flocculation of asphaltenes, which would translate into less pipeline blockage. So this graph shows a general idealized sort of results that we expect. Enzyme A, a single enzyme, will involve the least amount of deflocculation. Enzyme A and B, just two of them, will be slightly lower, and then all three, we expect it to go down even more. So for these flocculation tests, we're going to break them off into subteams. For the single enzymes, we're going to break them off into 3 subteams for chloroperoxidase, lactase, and dioxygenase. And then for the combination of enzymes test, we're going to involve 4 subteams for each of the combinations that I stated previously. Our timeline sees in spring 2016, we will try and go through Launch UMD to get the funds to buy the materials and possibly purify the asphaltene samples. Next fall, we hope to perform the asphaltene separation test and then analyze the data. Spring 2017 will involve the single flocculation test. Fall 2017, we'll see the combinations of enzymes. And spring 2018, we will finish our data analysis and go and prepare for our thesis proposal. Our budget comes out to around $5,600, with most of the funds going to the enzymes. We would like to thank the Gemstone staff, Dr. Siddhartha Das, our mentor, our expert, Jeffrey Clauda, and our librarian, Miss Eileen Harrington. Citations. Any questions?
All right. Thank you. So, Dr. Claudia, you don't know this, but we have a tradition that our outside reader goes first with questions.
Okay.
So, that's you.
Sure. I have a lot of them. So just a comment, I don't know, reference styles for figures when you copy from a resource, it's best if you actually reference the figure number too, not just where you copy it from, because some citation requirements actually say that you actually have to say what figure you copy it from. Just a suggestion. But now to the science. So lactase, why did you choose lactase?
In our research, we found lots of, prior to when we actually we started researching enzyme, we were looking at bacteria, hence the name, Team Bacteria. We wanted to use bacteria in order to do that, but our previous mentor, Dr. Hutchinson, suggested we use enzymes instead, so that we could limit the confounding variables that an actual bacterial cell would cause. So we researched into the mechanisms these bacteria go through, and lactase popped up many times throughout all the species, particularly the Bacillus species, and we also found certain fungal species use this same mechanism as well.
But, so, I mean, the question is, from a chemistry point of view, why is adding that functional group gonna improve or reduce flocculation?
Hopefully it will reduce the polarity of the actual molecule and further provide certain, is it right if I go there?
Of course.
Yeah.
Lacase also produces the water which chlorperoxidase needs to do its reaction as well. So
Mhm.
there's that reason also.
So,
Go ahead.
so when lactase oxidizes these certain areas, like here you have a hydroxide group which is significantly more polar than the ketone, and considering the ketone is also attached to all that, and then also conjugates this this part of the carbon chain. So that would provide, decrease the amount of space that these molecules are having, which is a general cause of what flocculation
But
is.
certainly if you, I'm not saying that this is gonna happen, but when you add hydroxyl groups to your compound that can hydrogen bond to a ketone, you're gonna have increased interaction there. So, there's two driving forces. You say van der Waals interactions are, surely they're the main driving force for stacking and forming these, but the side chains are important too. So you have to be, I think if you add too much of this, you might actually potentially enhance interaction. Just a suggestion, I'm not sure it would actually occur.
You should note this down. Somebody note it down.
Okay, so I know you mentioned that the reaction model is just one example. It wasn't really clear in the proposal, but it's good that you said it was just one example here. Do you have any information on kinetics here? So you're proposing this directional motion of this first, this next, this second. Is there an idea of a rate limiting reaction versus ones that are fast? Why do you think one's first?
We generally do not know because these are heterogeneous molecules. None of them are the same, so we don't know whether each molecule is going to have a certain rate determining factor or not. So it's going to be a non-linear sort of mechanism. This is just a theoretical representation, just to.
Well, even if you had a uniform, which is not possible, but if you had a uniform structure, even that's complex enough. It's not just because of the structure being diverse, it's actually the mechanisms depend upon how much you have of the enzyme, conditions, and other aspects as well. Just something you need to think about. So, I guess one question I have in your methodology of what you want to measure, can you tell me why you want to do SEM?
I'm not exactly the expert in this, but
Anyone else who can
Yeah,
chime in and
I can
contribute?
try. So the overall purpose of using SEM is to look at not only the macroscopic images of these asphaltene flocculated precipitates, but also to use it as a size quantitative measurement for our data.
What's more plugging, a small aggregate, a small flock or a large flock?
That's the point.
Yeah.
Which one is? Which one plugs up a pipe faster, small flocks or large flocks?
I mean, it's a cascading reaction that happens. It starts from a molecule level, then it becomes.
So it gets bigger and bigger?
Yes, yes,
Okay.
bigger and bigger.
But SEM shows you, the scanning electron microscope just shows you a precipitate. Gives you no information on too much on size. Like if you're using,
gives you a
if you had
distribution.
if you had a solution of aggregates, dynamic light scattering would give you information on those sizes. Here you're looking at already precipitated, flocculated asphaltenes, which is already bad, right?
Right, but here, one thing can be done is that, and maybe it was not very clear, so the flocculation becomes, visible in the naked eye when it becomes larger than of the order of micron scale. But it may be of the order of, it is of the order of few nanometers that is not becoming visible to our naked eye. but it is there. So what? So if they take a solution of that, those kinds of an asphaltene, which is not visible to the naked eye, but they do an SEM, of course, not of the solution, but after evaporating it out.
Well, I
then-
guess my argument is why not use dynamic light scattering?
Yeah, that can be one of the,
Which
yeah,
is-
yeah,
which
that
will
can
give
be.
you, probe you in situ size of.
Right,
of-
right, that can be one, but the challenge would be, I'm not sure how much dynamic light scattering would be amenable to something like a mixture of, when the solution is a mixture of toluene and enheptin.
So does the team have an opinion on I know you presented this, the SEM, but with the other technique of quantifying size, do you have any thoughts on which other alternatives might be available?
I think we'd have to look into it.
We have looked into it significantly, but we believe that SEM may be the most.
Accessible.
Yeah,
as well.
it's
So
more
there's,
accessible at
just to
university.
let you know, there is a DLS lab on campus in IPST and chemical engineering.
I see,
So, and they do asphaltene
okay,
analysis, so
Yeah,
it is available.
I see,
If you look at
good, good.
Dr. Nisimo.
Thank you.
Doctor?
Nisimo?
Okay,
Okay,
okay.
Cal Nisimo.
Okay.
Anisimov, yeah, Anisimov. Okay, please, Dr. Anisimov. Anisimov.
Yes. So just a suggestion for that. So the other concern I had was with how you characterize your Alberta asphaltenes. So you say you're gonna purify it and characterize it. How are you gonna purify it and how, because there's inherent variability here. And when you're doing these experiments on various different enzymes, incorporating that in the analysis is gonna be crucial. And having the right amount of data and statistics for that is gonna be important.
Which slide is that? I just lost it.
So in general terms, this is defining your conditions, your experimental conditions, and make sure you have them defined accurately so that you can relate your findings to the correct situation, right?
Okay.
I'm sorry, what was the
So
question?
the question is, so when you're going to do these experiments, which are supposedly soon, how many measurements are you gonna do? How are you gonna characterize that, purify and characterize it? So you're gonna characterize it with what? FTIR, I guess, is one of the techniques. How are you gonna purify it?
There's a standard test method or method for purification of asphaltenes by the American Society of Testing Materials. Yeah.
Mhm.
So we were going to use that to purify the asphaltenes.
Does a procedure like that give you guidelines or criteria for when it's purified and when it's not? You have quantitative goals to reach in the purification process?
Or what do you get when you ask for this product from Alberta?
Oh, what does Alberta send us?
Right.
It's a solution of asphaltenes in
Toluene.
toluene.
And they give you a CSA, carbon, sulfur, hydrogen, oxygen combination of the volume, the weight percentage. Because that weight percentage varies from asphaltene sample to sample, it's not constant. So they will give you that, and also they will give you this kind of a structure in like which structure you should expect. And if you do, I think, some XPS or XRD, I think you will get, which gives you those peaks of those elements, so XRD or XPS, I don't remember.
XID, FTIR.
Yeah, FTIR, yeah. So if you do that, you will get those peaks, and from there you can actually quantify what are present. And
Right, so I mean, I think that characterization is important because those enzymes attack different parts of this asphaltene, so you need to be consistent and homogeneous if possible with doing the different enzymes with the same type of asphaltene if possible, or somehow incorporating that knowledge when you're doing the measurements.
I think we're looking at the FTIR before we put the enzymes in, so we'll have
Right.
like before and then after.
Okay, good.
Yes, and part of the research that we, for the expected results, if we see more of like, say, oxygen peaks in FTIR, then we'll understand that we have oxidized and changed the structure of the asphaltene. We won't know what the physical properties of those asphaltenes are unless we actually observe what they do, but we will understand that we've changed them.
I'll follow up with a question about your infrared spectroscopy. That's a word I have trouble saying. Something like FTIR, the peaks you're talking about, can you infer quantitative or concentrations of those functional groups based on the peaks?
Quantitatively, not precisely. Where are we?
It's a very qualitative measurement.
No, no.
It's just for comparison.
So it's telling you whether something is present or not present?
Yeah,
Yes.
it tells you
Yeah.
if a change has happened.
Right. So you need, to get back to Dr. Claude's question, so you need that clean characterization up front, so you know what you're starting with. So that when, you're not gonna have data at the end saying there was 0.37% this, 0.47% that change. All you're gonna know is, in the beginning, this peak was here, and at the end, this peak wasn't here. So that changed the characteristic of the
The
molecule.
absorbance level gives you relative amounts, so you can quantify it, and not quantitatively,
Yeah, yeah, yeah.
qualitatively you can.
Yeah, qualitatively you can say, okay, this is present, this is present. You can't quantify. So is there any technique that can actually quantify it? Let's say I have a asphaltene and the same question.
There is,
Can-
I'm not at liberty right now to remember what
Okay.
techniques are, I mean, that's how they quantify it right when you get it.
Right.
Or is it mass spec or something else?
Okay.
I don't know,
Okay.
I'm not sure. So with data collection,
But sorry to interrupt
Yeah.
you, but in terms of asphaltene, there are rarely studies that have quantified in terms of the weight concept or the weight percentage or the volume percentage of the functional groups.
Yeah.
You typically asphaltene, all measures are like the physical weight, like in grams or kilograms of the precipitated asphaltene, or the weight percent of asphaltene dissolved in a toluene solution. So that is what people do typically, rather than getting you, okay, in this molecule of asphaltene, or this would be the percentage of hydroxyl group. I haven't seen those.
There
figures.
there has to
Okay.
be, I know this. I mean, so if you look at review literature on, they say how much of that compound
Mhm.
moiety is in these
Okay.
structures, that is there.
Okay.
It's chemistry,
Okay.
so I think it's a fundamental thing that there is
Mhm.
information on.
Okay.
In terms of data collection, you say you're gonna measure this. What about reproducibility? How much replication are you gonna do? Statistics on your data, et cetera?
I think all of the measurements that we were going to do were going to be in triplicates.
Okay.
So we would have at least 3 results per test or per concentration. And for statistics, we were going to use ANOVA to
Okay.
characterize
Just wanna
them.
make sure those.
So the triplicate in this field, that's sufficient usually?
That's what we read in the literature, that would be the starting amount that we should do, and then if we have time, then we can continue with 5,
The
7.
only reason I ask is from my point of view, not knowing this chemistry at all, that you sound like you're starting with a very complex compound to start with.
Right.
So you're gonna have more noise than you would have get more of a pure crystalline type material.
Sure.
Right, right.
So I would expect it to be noisier data you're getting, so triplicate might be a good place to start, but you might be looking at
Correct.
quadrupling that.
Right.
I would recommend to do the quadrupling part when the cases that they investigate are their original results. So when they are sort of like validating the existing experiments, just to start off with checking, so they have the experimental benchmark already there, results already there. So there, if they do a thrice and can get that, I think that's good.
Good, okay.
Yeah, I think that's, oh, one more thing. So based on your literature search and enzyme information, do you know how much enzyme you're going to need and how well that works in the solution that you're using?
I think we're just gonna have to test it out.
Okay. But I mean, some of these, there's information in terms of past studies which looked at other compounds, but you can see that type of concentration level. What was the level for those, and what type of solvent was used in those studies?
I can't remember the exact numbers, but they were generally in microliters and micromolar.
Okay.
Um,
And are these active in an organic solvent like you're proposing?
I believe so, yeah. Usually they contain some sort of pH buffer as well to control pH so they can work at their optimal pH level.
Well, usually pH buffering is done in aqueous solution. So I think you're proposing to do something in an organic solvent. So, again, think about that when you're
Yeah.
designing something.
pH buffer seem just pop up a lot.
What typically does there, so once, and there's a very interesting point, I mean, this is completely, I mean, it's a very later stage of your research. So once people dissolve asphaltene in toluene, they also add water.
Yeah.
Because what they want to see is, as you said rightly, that pH, because asphaltene can demonstrate pH responsive charging, which is very, very significant. So because they have this carboxylic groups that ionize to produce CO minus ions. What the problem is, the good thing of that kind of ionization, not problem, the good thing is that they will now create a sort of an electric double layer around them, and that those asphaltene moieties will undergo a sort of a self-repulsion.
Mhm.
So that self-repulsion has been sometimes proposed as something that is working against flocculating. So it is a mechanism that is sort of hindering the van der Waals induced attraction.
Mhm.
So people have tried this methodology as well. So maybe that's a good idea to just try that part as well. So that's that component as well. Have asphaltene, have some water, and see what happens.
So another aspect for the team to consider.
Right.
Thank you. I'd like to think a little bit about your whole experimental design. So you can go back to that chart you showed with the single enzyme treatments and then the combination enzyme treatments.
This one?
No,
I
the
think
bunch of boxes.
the subgroup division.
Oh, ah, crap. Yeah,
There you go.
There
Okay.
it is.
So, from what you told me about the chemistry, that a certain enzyme is going to attack a certain part of the complex aromatic mass that is this molecule, right? And it's going to cleave some bonds, and it's going to open it up, and then some other enzyme is going to chew on some other part of it, and some other enzyme is going to chew on something else. And I understand very much your first row there, but you want to see what activity each of the isolated enzymes has. And I understand the idea of your second tier of looking at the combinations in cocktail. What seems to me really intriguing is what's the sequential? If you treat it with the chlorperidase first, is that better than treating with that last? Or is that case treatment first more impactful than putting it second or third? And does sequence of exposure to the different enzymes in series matter? So I would think a series experiment would be very informative, because when you get to a cocktail experiment, which I'm calling the bottom row, that's informative too, but you don't have as much a mechanistic understanding as what's going on in what cocktail. That's my thoughts from a non-chemist, but what do you think about that?
That is a good question, because if we do put it like how it is, we'll get basically both of what you're saying at the same time. Like one's gonna go first than the other, but then also the other one's gonna attack first than the other one. So we won't know, so I think we can consider that.
So you were thinking of as a cocktail all at once?
Yeah.
A lot of the literature
That's the way I read it.
review,
Yeah, I just want to make sure.
Yeah.
talked about saying that it would be optimal to just have a cocktail. So we just wanna test that.
But you would like us to
You are
test
sequencing, yeah.
both the nonlinear and linear mechanisms that we were proposing in the mechanism.
Well, I'm not asking, I'm just curious as to whether if you're trying to do this commercially, and I have no idea what the infrastructure looks like that you would do this commercially, but if you had 3 vats of enzymes and you need to inject them into a system, do I need to pre-mix them and then inject them, or is it more efficient to inject one, then inject the other, then inject the other? Just from a functionality of a plant point of view, how would you engineer that? And so I'm just
I
asking from that point of view.
What we were thinking, because we were going to do bacteria, and since they contain like the combination of enzymes within them, we were trying to sort of mimic that process by doing the combination, but that's a good consideration.
Just to add a point to support his idea, there are 2 issues here in the idea that you said, like have it sequentially. One, let's say we have first, I want to call it like enzymes A, B, and C because they're 2 complicated names. So let's say after adding A, let's say we give it sufficient time and then we add B. We are not sure the product that has been produced by the reaction of asphaltene with A is a highly stable product.
Mm-hmm.
They may actually now interact with something may form some hydrogen bond somewhere. And now when we add B, maybe we are working with a completely different entity that we don't know.
But that's a good outcome.
Right. We have to see. I mean, if eventually the outcome is known, known in the sense what we expect is known, that we need to have a very less amount of flocculated asphaltene with addition of these N-alkanes.
Mm-hmm.
We add N-pentane, N-heptane, and we have to get to a situation where things go down. The amount of flocculation goes down. So yeah, that's a good point.
Mm-hmm.
The second thing to consider in this case is to know the time window of a given A, or enzyme A reacting with asphaltene, when the reaction, like what is the rate kinetics?
Yeah, that's another question I had, how long it stays active.
Right.
And I have no idea, but I mean, is it 3 seconds or is it 3 weeks?
Yeah, so,
Yeah.
no, but I think literature is there. I think literature talks about this individual enzyme and this reaction with asphaltene, right? I mean, do they give an idea about the time window, like how long they have?
I believe they did. I can't remember, again, like the concentrations and
Okay.
solvent. I can't remember.
Well, those are good questions, and those are things that you should think about as we go along. I want to get to some more detail about your presentation, okay? You flip back in the beginning, the slide you showed of the aerial view of the extraction plant up in Canada somewhere.
They're called tailing ponds.
Tailing ponds, that's it. Okay, did you take that picture?
No,
That's what that little number 8 is up there?
yeah, that's our.
Okay, just for future reference, put that citation and that credit on that so I can see it all at the same time. Okay? And that goes with your other footnotes as well. I don't want to have to wait to the end as a viewer to remember, oh, that photograph of the tailing ponds had an 8 on it, and I have to go look at your last slide that you may or may not show me at the end of this time to see what number 8 is. Just go ahead and put it on there, and with your references of some of the detailed technical information you presented, which had some footnote numbers as well. If it's important to source them, put the source on the same slide. Okay, I know there's different options and ways to do that, but I think from the clarity of presentation sake, it's much easier for the viewer to see.
To build up that for your final thesis, because it will be published through the library, any images or figures that you reproduced from another source that you did not create, you do need to get permission.
Permission, yeah.
Um,
For this, we don't need permission, but for that, we
No.
have to get it yeah.
Yes, but for the final thesis, because it is published through the university. you
Yes,
do need
anything
to-
that is published, you have to get.
Okay,
And your librarian can help.
very helpful with that.
I mean, it's straightforward, I can do it right, there's a copyright clearance form, and you can do it right away, so.
And
They won't charge you anything.
if you have images that you created yourself, more for the fact of not having the viewer question whether you created that yourself or whether you borrowed it without citation, cite yourself. Who made it? Just cite it up there as whose image it is, and that eliminates any question there. Okay, now I'd like to go towards the middle of the presentation where you showed a figure on the separation test. There.
Oh, yeah.
Yeah. Are my eyes real bad or is that really blurry?
It's a little blurry.
It's
Yeah,
very blurry.
and you borrowed that from somewhere, right?
Yes.
Yeah.
There's a reference
There's
in
a
that.
reference.
The reference is the footnote on the subscript,
Right.
it looks like a 17 from here.
Yes.
Right, okay, well, it's cited, but even if you cite it, if the image, if the best image quality you can get is that, you can't use it, that's just not good enough. Either redraw it, or find a better image of that same figure to use. Okay, that's just not good enough. Okay, it really is not, and you will never get that through a publication process. Okay, you have some things?
I have a budget related
Sure.
question, related to your timeline. So you've already missed launch for this semester. So you can certainly do it in the fall, and the application would be due over the summer, and I wanna see that before you submit it. But what's your plan if you aren't able to do launch? How will you be able to conduct your experiment if you don't have access to the funds to buy the enzymes before the summer? What's your plan B?
Hopefully we'll look for grants that can fund our research, and we may look into certain oil companies that may be willing to fund this research regarding oil sands.
So is this more important to the oil companies or pipeline companies?
Probably oil, because they
Oil
kind of get the
companies.
slack
Oil
if
companies.
something bad happens.
Oil companies wants to talk to pipelines with refined oil.
Okay.
They don't want to give a bad oil to the oil company, to the pipeline companies.
Okay, so any more specificity as to how you might start this grant search process, which it is going to take some time.
Yeah, I mean, and particularly in this environment, Canada is really doing badly now. I mean, particularly Alberta, when I left, it was a gold mine, but now, maybe because I left, so.
That's right. They lost their treasure.
Yeah, so it's, I mean, the price of oil has been globally coming down so rapidly, that because their break-even point was, I think, $80 a barrel, so.
I will throw an idea, if you contact the, I don't know the right name, but the industry support group for petroleum, they have offices all over DC, they're a very powerful group. They oftentimes have programs to support research and support educational efforts. And they may find something like this very to their advantage to show that they're helping support work like this. Not that they have a huge vested interest in the outcome, but they like to show that they're supporting research at a young level. So don't look past those opportunities too. And sometimes that takes a phone call or two to find the right person to talk to. And don't be afraid to sell your project and have that elevator speech ready when that phone rings.
So what if you don't get $5,000?
I think we'll have to reevaluate the
The other choice of enzymes.
Yeah.
Because the enzymes are what are constituting most of our budget, and if they are too expensive for us to buy, we're gonna have to reevaluate, and because we do have a master list of other enzymes to use, but these ones were the most beneficial, so we could look at that list again and go back.
Okay, so the prices for the enzymes is about $3,000 of your total $5,000 budget.
Right.
That's catalog price,
Yeah.
whoever sells these enzymes.
Generally
Sigma.
Sigma.
Yeah.
Sigma Aldrich?
Yes, they will.
Okay. Have you scoured the campus for someone who just might have some?
Something that we need to do, but
Yeah.
we haven't come to that stage yet. So.
Okay, there's a lot of faculty, a lot of labs on this campus who have resources that they'd be very willing to let a Gemstone team utilize. And they don't know you're looking for it unless somehow you hunt it down. Someone came to my lab and said, hey, I would love to have a half a liter of this enzyme, and I have 5 liters sitting on the shelf, it's like, or in the fridge, sure, you can have it. So don't look past just asking.
So then, what are some of the potential impacts of your findings? So say you are successful, you're able to decrease flocculation. What is the outcome?
The outcome of this is, it's a small step towards having a biological function that could decrease the flocculation rate and therefore provide better transportation by pipelines. So if we, yeah, let me get back to that slide. Yeah, where are you?
But what about, so now let's say it works, and now there's no more asphaltene in Alberta. What's the, have
What
you
else could
thought
we use for
through
that?
of sort of, one, the consequence of your findings, but also other implications? So you said at one point that if you were able to do this, you could power for 70 years, provide resources, right? But then after 70 years, is it gone? And then what?
Well, we're just hoping to make the fossil fuels more available while we're still transitioning to renewable energy infrastructure, because that's going to take a long time and it's also very expensive. So we can't have that right now. So we're trying to access these heavy crude oil resources while that transition is being made, so we can still sustain ourselves as we're getting there.
A big thing that would, like the main benefit of what we're doing is it would allow oil to flow more efficiently through the pipelines, but also reduce the risk of damage to the pipelines and them breaking. If you think about something like the Keystone Pipeline, a big objection is people don't want a pipeline that may or may not break in their neighborhood. So with this kind of, with this reduced risk of flocculation and damage to the pipelines, it would be a lot easier to just to have the pipelines and be confident that no environmental disasters would result from them, and it would just be a boost to the oil industry.
We're still very much dependent on oil now, and the transition to alternative energy isn't going to be for a while, so.
Okay, so the lower viscosity crude oils that don't have this huge problem, do they contain asphaltenes at all?
Yeah.
They do,
Yes,
but in
there's-
smaller percentages.
There's still occasions where like lighter oil breaks, it just depends where.
So could your research results be applied to any oil system?
Yeah,
We think so.
most likely.
Just not the difficult ones in Alberta?
Yeah.
Yeah, but that's why it would
Yeah.
have the most impact.
Right, because that's their biggest problem.
Mhm.
But
Yeah.
But it could be applied anywhere. It could be applied as like a safety serum for Gulf of Mexico oil. It's lighter.
Mhm.
Theoretically, sure.
Theoretically.
Okay. Alright.
Something about as a team, how will you all hold each other accountable through the research process and make sure you're communicating, particularly given that you've divided your sub-teams based on enzyme? How will you make sure that you have some consistency and don't risk
Are you-
confounding variables?
Are you asking about the methodology?
I'm asking as a team, how will you function? Because if one sub-team conducts an experiment via one protocol, the other sub-team's using another protocol, and they don't match, that could be problematic, right? And then how will you make sure you're communicating as a team so that you're all following the timelines that you've set forth and giving their deliverables by the agreed upon dates?
I believe that we're gonna have a couple of people on our team act as like lab liaisons, like writing up the methodology and making sure that the protocols that each sub-team is going through matches up with each one, and they're collecting their data accordingly. So we're gonna have a couple people manage what's happening in lab and coordinating who goes where and who does it when.
I mean, in experimental design, the safest way to do it and avoid confounding variables is not to do it in series, but to do it randomly. So not assign a group a compound, but randomly put a group on a compound, another group on another compound, or have groups do multiple compounds. So the group effect, if there is any, is washed out in the statistics.
Okay.
So that's another thought. So if you're willing to do that, that's a better experimental design than having one group do one thing.
Yeah. Because like you two might be a whole lot higher level of skill in the lab than you two. And the enzyme you're working on is going to perform better just because you have better technique skills.
Okay.
So yeah, that's a very good point. And it's not a trivial factor. We had a team a couple years ago who, I won't go into the details, but the ultimate, they had different teams working on different aspects. And at the end, these different physical modules were going to come together, which involved plumbing pipes. Okay? And when they got together, one team built their system with 1 inch pipe, another team built their system with 1.5 inch pipe, and when they came to put them together, it wouldn't work. And we were dumbfounded and said, didn't you all agree on to use the same size plumbing? No, we never thought about that. So their whole concept couldn't be ultimately taken to fruition because they couldn't rebuild the whole thing. But that's a very physical example of sub-team lack of coordination. So don't go there.
And we asked all the teams how they'll hold each other accountable, because at this stage, you're sort of at the starting point, and you're more focused, but in a year from now, you wanna make sure you're just as focused as you are now, so making sure you're staying on top of any potential accountability issues is important.
We have a couple people on the team right now that are keeping track of people, and there's certain inner deadlines that we have, even for this proposal. And we make sure that that person or that group of people is keeping on top of, has this person done what they've done? Do they know what they're doing? And do they know when they have to do it?
Those individuals have a title,
Assignment trackers.
assignment trackers.
I have a title,
If it
what's it called? What do you call it? Liaison. Yeah, group liaison, yeah.
Okay. All right, we always like to end up with the team having an opportunity to ask us any questions you may have. If not, we have things to do. Well, you did a good job. Thank you.
This is the biggest presentation in your life till date in terms of time, not the importance, in terms of the time.